In this video, I'll be talking about the series combination of resistors. Resistors can be connected in a series or in parallel. There are different configurations in which resistors can be connected in a circuit. So here first I'll talk about the series combination of resistor. So as an example, I have chosen the 4 resistors. It can be multiple resistors connected in a series. So 4 resistors are connected in a series combination. When I say series combination, what does that mean actually? So, and here it is a battery and the 4 resistors are connected. The resistors that are connected in series combination, the same current flows through each circuit or each resistor. So the same current is passing. When I apply a potential difference, then the current will be passing through the circuit. And the same current passes through each resistor. It has the only one path to travel. The path is this path here. So if it has the same path, that means the same current will be passing through each resistor. Now, as the same current is passing through each resistor, but the resistance value is different. Let's say R1, R2, and R3, R4 are different value. That means the potential difference across each resistor will be different. Okay, so if R1, R2, R3, and R4 are different, then the potential difference across each resistor will be the different. The net resistance value, when I say the net resistance value, all these resistors R1, R2, R3, and R4 can be assumed to behave as one single resistance. That is called the effective resistance or the net resistance. What is the net resistance? The net resistance is the resistance that R1, R2, and R3 and R4 together behaves as one resistance, and that is called the net resistance or effective resistance. And if they are connected in series combination, then the net resistance or effective resistance is given by R1 plus R2 plus R3 plus R4, just a scalar addition of all the resistance value. So in a series combination, the resistance value is always greater than the individual resistance because they are connected in series or they are added together. Okay, so the net resistance is always greater than R1, R2, R3, or R4, or it is greater than the greatest resistance. Okay, so this is the one thing you have to keep in mind for the series combination. So if more the resistance are connected in series, that means the total resistance will be always greater because it is adding more obstruction to the flow of electrons or to the flow of current. And the one thing I just mentioned here, the potential difference across each resistor is given by this formula here. V1 is equal to IR1 because how do I measure the potential across this resistor? The one way to measure this one is, first you have to find out what is the current passing through the circuit. If we know the current passing through the circuit, and we know that the same current will be passing through each one, so once I know the current, then I simply multiply by R1, then that will give me the V1. Or in other words, I can write down here, the V1 is equal to I times R1, V2 here is I times R2, V3 here is I times R3. I think this has to be R3 here. R3, and V4 is equal to I times R4. Okay, and the one important thing is, so this is the potential difference across each resistor, and if I add them together, that means if I add V1 plus V2 plus V3 plus V4, it has to be equal to the applied potential difference, or it has to be equal to this V here. Now, because this V is now distributed among each resistors differently, and if you add them together, it has to be equal to the applied potential difference. Okay, so this circuit just denotes or represents that all the resistors are replaced by one single resistance in series combination. And once you know the series combination or effective resistance, then you can simply calculate I, and I will be simply equal to V divided by RS. Okay, so here I just talk about the series combination, and let me give you let me explain this one through a simulation. So I'll just explain here using a simulation here. So here I have connected four resistance: 100 ohm, 200 ohm, 300, and 400 ohm. And here I have applied a potential difference 700 volt, and this one is a switch, so it can be turned on or off. Okay, so this one is open circuit now, it is not closed, so there is no flow of current. Okay, now I'm going to close this one, and you can in fact choose the different kind of symbols here, like this way or this way, whatever you prefer. Okay, so this is the this is how we represent in our paper, so I just like to use this way. And now I'm going to connect this close the circuit here. So you see the current starts always flowing here. So the current always flow from positive to negative terminal. You see here the current is flowing from positive to negative here. So in this case, going from positive terminal to negative terminal. Okay, so in this case, as we have four resistors, the total resistance will be 100 plus 200, 300 plus 400. If you add them together, how much current you will have? 4, 7, 9, and 1. 1000 ohm. Okay, so 1000 ohm, and the applied voltage is 700. Let me change this one just to make life a little easier. I'm going to make it 1000. So 1000, and then our resistance value is also 1000, so the current should be 1 ampere. Let's measure this one is here, and you see here the current is 1 ampere, and it doesn't matter where you measure the current. And this is an ammeter, that means it has to always be connected in series. Okay, it doesn't matter where you measure, that means the current flowing through each resistor is exactly the same, or at any point in the circuit is exactly the same, 1 ohm. Okay, so now we talked about two things here. The current flowing through each resistor is exactly the same. Now the potential difference would be the different. And as this resistor 400 ohm has a more resistance, that means the potential drop across this one should be greater, or should be the highest among all. So let's measure the potential difference. So how do I measure this one? So just choose one point here and one point here right now. So this is 400 volt. That means out of 1000 volt, 400 is dropped across this one. So let me measure across this one now, across R2. So 300, and now you got the idea, 200, and then here it has to be 100. You see here 100 volt. And if I measure from this point to this point, it has to be 1000 volt. That is the applied potential difference. Okay, so this way you can, or using this simulation, you should be able to measure the current, you should be able to measure the potential difference, and then again you can use this simulation to calculate the current flowing. But what I would like you to do is that you should be able to calculate by yourself using this formula, or you should be able to do it by your own. Okay, and you can use the simulation to verify your the mathematical answer. Okay, so this is it for the series combination of resistors. If you have any questions, write down your questions in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.